everyone, welcome to the session on Genius Chalk. In today's video, we are going to cover the next part of number system. If you have not watched the previous videos of number system, please go and watch them. And let's take the next part forward. So I am Saurabh, welcoming you all in this session for Genius Chalk. So let's start with the first question of the session. The first question says, it's 1904 into 1904. So we have two ways to solve this question. One is we can write this as 1904 square, as this thing is written twice. So I can write like that. And further, if you use this formula, that is a plus b whole square is equals to a square plus 2ab plus b square. If you use this formula, it is quite easy to solve this. So I can break it like 1900 plus 4 and whole square. And here you can see that this is a and this is b. So a square, that means 1900 square plus 2ab, right, plus b square. What is b? It is 4. 4 square is 16. That means you just need to solve this. So this is 4 to the 8, 19 8 is 152, 00 plus 16, and this part is becoming 15216. Now you know what is 19 square, that is 361, and I have two zeros here, so if I square it, it will become 4 zeros. If you add it, it will be like 15216. Just add this, have your answer 3625216, and that is option 3. So this is first way to solve this question. Let's move to the next way, that is base method. We have discussed. If you have not watched my videos of base method, please watch them. So here we write the number like this, and we take the number, a number as base which is closer to both the numbers. So you can see 1900 can be taken as the base. That means you can take 900 or you can take 2000 as well. But if you take 2000, it is very difficult. It will be 96 and 96. So this is quite easy. So this is 4 more than the base. You can see 1904 is 4 more than the base. So 4 4 is 60, right? Now as I added up with 4, and here also 1904 must be added up with 4. So you can write 1904 plus 4, that is 1908. And what was the rule? The rule was that this number which we have got here, this must be multiplied. The number which we have got onto the left hand side, that has to be multiplied with the base. So this is our base, and this is plus plus, this is plus, and then it has to be added. So if you solve this, it will be 19 8 is 152, 1 is carried, 19 9 is 171, and this becomes 172, 17 carry, 19 1 is 19 plus 17, 36, and this will be plus 16. So you can see these two places will be taken by 16. So answer is 3625216. So that is the third option, right? So this is the answer of the question. I hope if you have understood the second way, that is more convenient and easy in the exam, so you can try with the second method as well. All right, let's move to the next question. Which one of the following is a prime number? You know what is a prime number? The prime number is a number which is not divisible by any number except 1. So what was the rule that we have discussed for a number to be prime? The rule is that we need to check the nearest square of this number. So what is the nearest square? That is 169, and this is the square of 13, and 13 itself is a prime number. So I need to write all the prime numbers less than 13. Okay, and I cannot take 13 because 13 is more than 13 square is more than 161. So I'll divide this number just by all these prime numbers. If this number is not getting divided by anything, that means that is a prime number. So let's divide. For this we need to be very clear with the divisibility rule for all these. So 2 divisibility rule is last digit is even, so this is not even, so not divisible. 3, the sum of the digits is 8 here, which is not 9. 8 is not divisible by 3, so this is also cancelled. 5, the last digit should be 0 or 5, no, not. 7, what is the rule for 7? That is you can divide it also directly. 7 to the 14, 70, so this is divisible by 7. Or I have told you the rule in the previous session, take the first 2 digits and multiply them with twice the last, and so this becomes 14, and 14 is divisible by 7, so this number is divisible by 7, so this cannot be the prime number. Okay, now go ahead. 221, we already have done this in the previous session, I guess, part 2 or part 3. You can check that this number was divisible by 13, and if you write the perfect square near to it, that is 15 square, that is 225, and in this list you need to add one more prime number, that is 13. So this 221 is divisible by 13. It is not divisible by anything else, but yes, it is divisible by 13. So you can see that this is 2 to 1. You can check 13 ones are 13, and 13 sevens are 91. So this is divisible by 13. So we can say that this is also not a prime number. Now come to the fourth one. The fourth is 437. If you see, 437 nearest square is 441, and that is 21 square. So you need to add here in this list 17 as well as 19. If you see, check the last digit 19, because it's a big number. So start from the last one. So 19 2s are 38. Let's divide it. I hope you are getting my point. 19 2s are 38, and that is 57. 19 3s are 57, that is 0. So that means this number is also divisible by 19. So what is the answer? This must be the answer. And just to verify it, we can check what is the nearest square. I guess this is 361, that is 19. So we can check up to here from 2. Yeah, we can check up to 19 as well. Yes, because 361 is less than 373. So if you check by 2, no. By 3, no, because it's 13 is the sum, so this is not divisible by 3. 5 also not. The last digit is not 0 or 5. 7, 37 minus twice of 3, that is 6. 31 is not divisible by 7, so no. 11 means 3 plus 3 6, the sum of the digits at odd places minus the sum of digits at even places, so this is also not divisible by 11, because this is you see, this 3 6, and 7 minus 6 is 1. So the difference must be either 0 or a multiple of 11, so this is not divisible by 11. Also 13, if you see, 13 2s are 26, 113 is not coming in the table of 13. 17 also, 17 2s are 34, 3 not coming. 19 also we have checked, it is not coming. 19 ones are 19, and then it is 183, it is not coming in the table of 19. So this is the answer of the question. So do remember this trick for a prime number. All right, next, the smallest 6-digit number exactly divisible by 111. So this type of numbers we have discussed earlier as well in the previous sessions of number system. Smallest 6-digit number, what is that? That is 100, 3-digit, 4 5 6. Divide it by 111. So this is the first way. You divide it like this and get the answer. But the second way is to directly check the options. If you check the, see, what is 111? This is the sum of the digits is 1 plus 1 plus 1 3. This number is broken as 3 into 37. That means 111 has to be divisible by 3 as well as 37. Now check which options are not divisible by 3. If they are not divisible by 3, obviously they are not divisible by 37 as well. So they are obviously not divisible by 111. So cancel all the options which are not divisible by 3. So if you see, for divisibility of 3, the sum of the digits should be divisible by 3. If you check 1 plus 1 2, 2 plus 1 3 plus 1 4, this is not divisible by 3. 1 plus 1 2, 2 plus 2, 4. This is also not divisible by 3. Only two options are left. Now you can check it manually. 1, 1, 1. If you take the first option, 1, 1, 1, 1, 1, 1, you can see this is clearly divisible if you even solve it. 1, 1, 1, 1 is a 1, 1, 1. Remainder is all 0. So this one will be here. For that, now this triple 1 is cannot divide this single one. So we have to take 0 here. Right. After that, this one is again coming down. So this is one more 0. Again, it's not cancelable. It's just 11. So this one has to be here. And this is cancelled. 1, 1, 1. So this is remainder 0. So answer is A. If you see this also, this is not divisible by 1, 1, 1. Right? Yeah, this is divisible by 3, but not divisible by 37. If you check it, it's not. And moreover, the thing which you have to learn is 1, 1, 1. It is 3 into 37, of course. And here 1, 0, 0, 1 also. This can be broken. This can be broken. You see, this is divisible by 11. This is divisible by 7 also, right? So this is 7, 11 and 13. Please remember this is a special number in quant. And you see this is divisible by 7 also. 7 is 7, 3, 0, 7 4 is 28, cancel. 11, 1 plus 0, 1 plus 0, 13, 13 7 is 91, 91, 37 is 91. So 7, 11, 13 are the factors of 1, 0, 0, 1. And this is called a special number in quant, where the questions are asked directly from this. So do remember that and these two are the factors actually. If you see any number, this is a rule I'm coming here now. If any number in quant is repeated 6 times, that will always be a factor of 1, 1, 1, remember, and that will also be a factor of 1, 0, 0, 1 as well. Suppose I write 5, 5, 5 and 5, 5, 5. Always remember this has to be the factor of 5, and if you solve this, this has to be factor of 1, 1, 1, 1, 1, 1. And remember this 1, 1, 1, this will always be, this 6 times 1 will always be the factor of 1, 1, 1 into 1, 0, 0, 1. And this 1, 0, 0, 1 can be written as 7 into 11 into 13, as these are the factors of this. And this can be written as 3 into 37. So any number in quant, any number in maths, wherever you see, if that is divisible by, or sorry, this is repeated 6 times, please remember these 3, 7, 11, 13 and 37. These are all the factors. Again, I'm repeating 3, 7, 11, 13 and 37. These are always the factors plus the number which is repeated. So that is obviously the factor. So remember the answer of the question here is option 1. All right, next question. The largest 5-digit number divisible by 91. So you break it like this. One way we have discussed earlier that take the largest 5-digit number, right, and just divide it, or else directly you break it like this is a factor of 7 and 13. So check which number is divisible by 7 and 13 both, that is the answer, but it has to be the largest. So the more safer way is this 91, you take it here, 91 ones are 91, 8, 9 not cancelable still. So this has to be, if you take 9 times, 9 ones are 9, 9 nines are 81. If you take it 8, 0, right, and 9, so this is 8. So 8 ones are 8, 8 nines is 72. If you see here, this is 81. So what is the largest number? I don't need this remainder from this, so I subtract this remainder from this, and that is the answer. So if you subtract 5 times 9, that is the largest 5-digit number. If you subtract this remainder, whatever number you get, that will always be divisible by 91. So this is my answer, that is second option. So this is more safer way to solve the question. Although you can also solve like divide by 7 and 13, then also you will see that this number is only divisible. All right, next. Now this is a number, it's actually a formula. You see this number is repeated thrice in multiplication. This number is repeated thrice. Can I say, if I take A as 768, then if I take B as 232, right? Now, if you see this A, this is repeated thrice. So can I write A cube? This is B, B, B. So this is repeated thrice. Can I write a cube plus b cube? Okay. Here also a square. This is a into b, that is ab plus b square. So this is what I'm getting. Now expand the formula. If you remember, a cube plus b cube, this can be written as a plus b. Okay. And further, a square minus ab plus b square. This is the formula of this, and you know this a square minus ab plus b square is there in the denominator, so just cancel this. What is left? A plus b, and that is my answer. So the answer of the question, just by reading the form, that is a plus b. So just add 768 with 232, and that is coming as 1000, and that is the first option. So make sure that you remember these formulas as well. At times they are quite useful. All right, question number 6. The smallest 5-digit number exactly divisible by 41. Let's find 41. This is my number, and you know this is a prime number, so it is not divisible by anything, so we can check directly. Can the first option be the answer? No, it's just a 4-digit number, right? Okay, so just check. The smallest 5-digit number is 10,000. Now divide 41 to 88. 18 is left. This 0 is coming here. Now read which number we can. 41 4s are 41, 5s are 5 1s are 40 5s are 200. So this must be 4 times. 4 1s are 4. 4 4s are 16, and that is 16 left. And this is okay. And now you can see this is not coming 4 times now, and this must be 3 times. So 3 1s are 3, 3 4s are 12. Yeah, 3 1s are 3. Yeah, this has to be 3. So now what is left? 7. This has to be 37. Okay. Now what is the smallest number? So obviously you need to subtract this from the dividend. So if you subtract, you will get 100. Sorry, this will be 99. If you subtract 10,037 from it, you will get 9963. But the problem is this is not a 5-digit smaller number. This is the largest 4-digit something, because 9 is there. That means I need to get the next number, so add 41 here, and that is the answer. 10. This is 1004. 1004. That is the second option. Or you directly remember, I have discussed this. Whenever you find the smallest number, remember, smallest number of any digit, whatever is the remainder and whatever is the divisor, take the difference of both. Obviously remainder is always less than the divisor, so what is the difference? 4, and add this 4 here in the dividend, and that is the answer. So 10,000 plus 4, that gives you 10,004, and that is the answer of the question. Okay, so be careful in these type of questions. Now there is a next term that is called GP. What is GP? GP means geometric progression. Geometric progression. Now this is a question asked from there. So this is like, if you write like 2, 4, 8, 16 and so on. Here you see these numbers are multiplied by 2 every time. You see? So this is called GP, where the multiplying factor is same. Or in other words, you can write the common ratio is same, like common ratio is 4 by 2 or 8 by 4 or 16 by 8. So here and there are two formulas. One is Tn equals to ARn minus 1. This is the thing which we have to use here, because how many terms are there? Like this is called as first term. This is called as first term A. This is second term. This is third term. This is fourth term, and so on. So this is called AN or Tn, the nth term. So this is the formula of GP, and this is GP. So I generalize it now. AR square, AR cube, and up to AR n minus 1. You generalize it like this. This is the first term where R is 0. Okay. This is the second term, R is 1. This is the third term, R is 2. This is the second term. This is the first term. This is the fourth term. So if you see the term and the power of r, that is one less. The power of r is one less. Remember, that is why for the term tn, or you can say the nth term, the power has to be n minus 1. So this is the formula, and this is called tn, the general term of a GP. So this is how we discuss that. We solve this question like this. So let's apply this here. What we have is 3, 6, 12, 24, and the last term is 384. That means this is the tn, this is the last term, this is given. We just need to find a. What is a? This is a 3. What is r? R is, you see, this is into 2, this is into 2, so r is 2, or you can say 6 by 3, this number by this number, that is 2, or you can say 12 by 6, again it is 2, so r is 2. Now apply this in the formula, we know, and get the answer. So let's apply 384, that is tn, it is equals to a r n minus 1. What is a? A is 3. What is r? 2. 2 की power n minus 1. 384, you just cancel it. 3 ones are 3, 3 2s are 6, 128. If you remember, 128 is nothing but 2 की power 7, and that is equivalent to 2 की power n minus 1. Now you know these two bases are same, that means their powers can be equated. That means we can equate the powers. I mean, I can equate this with this, because I know the rule. If a to the power m is equals to a to the power n, that means I can write m equals to n. Why? Because the bases are same and equality is there already. So just use it. So 7 equals to n minus 1. So n has to be 8. 1 comes this side. So n has to be 8, and that is the first option. I hope this is clear. All right. So this is your GP. All right. Next question. If x and y are positive integers such that 3x plus 7y is a multiple of 11. Now you need to find the value of x and y, where you have to get this as a multiple of 11. So this is hit and trial. You have to put the values because these are positive integers. So you can start from 1 itself, and 1, 2, 3, and so on. So let's start with the 1. If you put x equal to 1, this is 3 plus and 7 equal to 1, this is only 10. So x1, y1, not possible. If you put x1 and y2, let's suppose, so this is 3 into 1 plus 7 to 14. This is 17, not possible. This is not divisible by 11, you can see. Now put x2, y1, let's see. So x2 means 6, 3 to the 6 plus 7, again it's 13, so not cancelled by 11. All right, let's see. Next, try to put 2, 2. So 3 to the 6, 14 plus 6, 20, again not divisible by. Next, if this is 2 and this is 3, suppose, so 3 2s are 6 and 7 3s are 21. You can see this is 27, not divisible. Next, if you put 3 here, okay, and 2 here, let's see, 3 3s are 9, 7 2s are 14, 14 plus 9 is 23, not cancelable. Okay, what is left next? I put x equal to 3 and y equal to 3. Let's see. So 3 into 3, 9 plus 7 into 3, it's 21. 21 plus 9, it's 30. Again, not divisible by 11. Okay, suppose now put 3 4. So 3 3s are 9, 7 4s are 28. 28 plus 9, again 37, so not cancelable. Now put 4 3. 3 4s are 12 and 21. So 12 plus 21. Yeah, this is cancelled by 11. So guys, I have got the value. The value is x equal to 4 and y equal to 3. So this is the hit and trial you need to put in this question. Okay, now after putting this, as we have got the value, just check the options, which of the options are divisible by 11, as this is only the question which is asked. Okay, so just put the values. So x equal to 4 and y equal to 3. After putting those values, if the option is divisible by 11, That means our work is done, or else we'll. Okay. Uh, 4 4s are 16 plus 6 3s are 18. Is this cancelled? No, it's 34, not cancelled by 11. X plus y, 4 plus 3, 7 plus 4, 11. Yeah, this is divisible by 11. This is the answer. For further, verification, you can check 9 into 4, 36, plus 4 into 3, 12. 36 plus 12, 48, not cancelled by 11. 4x, 4 4s are 16, 9 3s are 27. This is coming in negative, no, not a point to solve because these are all positive integers. So answer of the question is option B. So be very careful in these type of questions. All right. The second last question of the session. In the division sum, the remainder is 0. Fine. Let's take the remainder as 0. Okay. As student mistook the divisor by 12 instead of 21. So if the student have taken the divisor 12, okay, and he's getting the quotient as 35. Suppose this is the number. So can I find the number? Yeah, I know the rule. This is divisor and this is the quotient, right? This is divisor and this is remainder. You know the rule. The dividend, this is called dividend actually. We have discussed this before. Dividend equal to n equal to divisor into quotient plus remainder. Find the value. Divisor is 12, quotient is 35, remainder is this. So just solve it. 12 5 is 60. So 36 plus, so this is number is 420. The number is 420. Now it says if the number is 420 and the actual divisor is 21, what is the correct quotient? This is the thing asked, correct question. So just divide this by 21. 21 2s are 42, 0 0. So 20 is the quotient and that is the answer of the question, right? So this is just on the basis of this formula you can solve the question. All right, next. All right, the last question of the session. Again, we have discussed this is 2 to the power 1 plus 2 to the power 2, 2 to the power 3 up to 2 to the power 9. And we need to solve this taking the sum of all. So what we can do, this is again a GP and this is called a sum of GP. Obviously you can add these all like 2 to the power 1 is 2, then 4, then 8, but that takes a time, then 16, then 32, and then so on. That takes time. So we'll not solve by this method, we'll solve by the formula. These are all GP because you can see this is A and their multiplication factor is R. Every time you are getting one extra power of 2 every time. That means this is GP, and we have done the general term of GP is Tn, and that is given by AR to the power n minus 1. And here we are not asked about the general term. Here we are asked about the sum of all terms. So let's find the sum of all terms. So what is the formula? Please write it. Sum of the terms of GP is A R n minus 1 divided by R minus 1. Obviously here R is positive or greater than 1 also. So, and if R is greater than 1, obviously this R has to be taken first. Okay. So this is the formula. There is one more formula, but that is just take the negative here common. So 1 minus Rn, and this is only valid when R is less than 1. Okay. Obviously you can see 1 is more now, so that's why 1 is subtracted. 1 is taken first and R is subtracted like that. So here you can see the R is greater than 1. So we need to use this formula here, the first one, because you can see the R is 2. What is R? R is 2. You can see because it's 4 by 2. 2 to the power 2 is 4. 2 plus 4, so 4 by 2 is 2. Similarly, this is 8. 8 by 4 is 2. Similarly, 16. 16 by 8 is 2. So R is 2. Just use this value and get the answer. So here, A. What is A? A is 2. R again is 2. What is N? N is the terms. From 1 to 9, the last is 2 to the power 9 minus 1 by 2 minus 1. You can see that we can find the answer. 2 into. What is 2 to the power 9? Always remember 5 1 2 minus 1 2 5 1 1. So what is the answer? 22. 2 5s are 10, and that is the second option, right? So I hope you enjoyed the session. Thank you very much. God bless you all.